Greetings and welcome to the Dr. J Vlog series. It's Thursday, April 24th, 2025, and on Thursdays, we consider knowledge and science. Today's question, are we alone in the universe? Countless people, myself included, have been fascinated by the possibility of extraterrestrial life. To have definitive proof that life exists in the universe would be one of, if not the, most profound discoveries in human history. Why? Well, we obviously know life exists here on Earth, but we don't have the conclusive evidence as yet to explain exactly how life emerged. Plenty of ideas, plenty of different kinds of evidence, but no definitive solution to that problem. And we only have an N of 1, meaning just the one case to try to work with to explain the origins of life. And so, if we could find life somewhere else, then that would do a couple of crucial things. First, it would double the number of cases that we have to work with, at the very least, to investigate the origins of life. And it would, more importantly, finally confirm that we are not alone. Now, I get it. I understand that some people are already convinced that we're not alone, in the sense that perhaps alien beings or life forms or their technologies have already visited the Earth. So I'll deal with that issue on another day. Today, I just want to talk about the recent evidence of possible life elsewhere on other planets having evolved beyond our solar system. So as Paulo Ghosh wrote last week in an article for the BBC, quote, there are some scientific discoveries that do much more than advance our knowledge. They create a shift in our psyche as they show us the scale of the universe and our place within it, end quote. So evidence of life elsewhere in the universe would clearly be one such discovery, leading to, in my view, a fundamental paradigm shift with respect to our understanding of our place in the universe. So while people have long been interested in the issue, though, the scientific quest to investigate such a possibility has a much more recent, no pun intended, origin story. What would eventually come to be known as the Search for Extraterrestrial Intelligence, or SETI or SETI, dates back to 1959, when Giuseppe Coccioni and Philip Morrison, two particle physicists at Cornell University, published a paper in the prestigious journal Nature titled Searching for Interstellar Communications. So their brief article then presented an idea that they'd been developing for years with their theoretical work on gamma rays at the Cornell synchrotron. Considering that the radiation beam produced during their experiments had the capacity to reach distances that could span the entire galaxy, they envisaged the possibility that these frequencies could then be used for interstellar communications. Now, aware of the large amount of energy that would be needed to generate gamma rays, they proposed that radio waves, which had the same basic properties but required far less energy to be produced, might be used instead. And so the way Coccioni and Morrison formulated their proposed research design followed the classic experimental pattern in particle physics. That is, they planned a series of trials and observations to detect something that had been predicted previously by theory. Okay? And still quoted today by SETI scientists all around the world, the closing sentence of the article phrased the research efforts in terms of the probability of success. Quote, that the probability of success is difficult to estimate, but if we never search, then the chance of success is zero. So again, the concept of probability, already broadly used in particle physics experiments, allowed these researchers to advocate for an empirical attitude towards their apparently far-fetched hypothesis. And then the following year, Frank Drake conducted the first SETI observations and organized a meeting at the Green Bank Observatory. The small group gathered by the astronomer reflected the breadth of expertise that he considered to be necessary for this daunting enterprise. So they included astronomers and physicists, biochemists, a linguist, and electrical engineers, among others. And so, to summarize the agenda, Frank Drake devised the famous phrasing of the equation that's come to be known as the Drake equation. So here it is. All right. So N is the number of communicating civilizations in the galaxy, which he estimates to be a function of the following equation. So R represents the mean rate of star formation, F sub p, the fraction of stars with planets, N sub e, the number of planets per star with environments suitable for life, F sub 1, the fraction of suitable planets on which life develops, F sub I, the fraction of those life-bearing planets on which intelligent life evolves, F sub c, the fraction of intelligent civilizations that develop interstellar communication, and L, the mean length of time that civilizations can communicate. And so the equation zooms in then from the immensity of the galaxy to the specific forms of life and intelligence that might emerge on the planets that would offer suitable conditions. And when multiplied together, they would give an estimate of the possibility of contacting another Milky Way civilization such as our own that was capable of radio communication. And in general then, a whole new field emerged known as astrobiology. And this really came into being or into its own and hit its stride with space exploration. Scientists began then to consider the possibility of life on other planets. And part of the challenge then would be to discover evidence of such life forms. And how do you decide where exactly you should be looking? Which star systems, which types of planets, and so forth. So until relatively recently, the focus for NASA's search for life was actually on our closest planetary neighbor, Mars. Makes sense, right? But that changed in 1992 with the discovery of the first planet orbiting another star outside of our solar system. We expected this to happen, but we just didn't have the technology. And finally then, it's only just a little over 30 years ago, we were able to definitively detect such planets. And so again, we've always suspected there might be these planets, but we really didn't have any conclusive evidence until that point. But since then, thousands upon thousands of planets outside of our solar system have been discovered and cataloged, and we expect the search then for these planets to continue well into the future. And so without recounting the full history of SETI, again, the search for extraterrestrial intelligence, it's important to note that we now have more than a half century of scientific research under our belts. And yet we still have no definitive proof that life exists elsewhere or outside of our solar system, to say nothing of throughout the rest of the universe. But we are getting very close, apparently, at least according to those who work directly in the field. So if interested, there's the work of the SETI Institute itself, to which I'll leave a link in the description below. So the Institute was launched just based on NASA's SETI program back in 1984. The Institute originally had just 2 employees, by the way, the founder, Tom Pearson, and astronomer Jill Tarter. And over the years, other research disciplines have been added to the Institute's portfolio, which provides home now for about 100 different scientists, all unified in the search for an understanding of life beyond Earth. And plenty of astronomers and astrophysicists located at esteemed universities all across the planet are engaged in the search to varying degrees. So these are quite serious scientists, driven by research dollars and motivated to truly produce the first unassailable evidence of extraterrestrial life or intelligence. Trust me, everyone wants to be the first. If or when someone comes up with the definitive, groundbreaking evidence, that will be the international news of the century, certainly of our lifetimes, and probably beyond. And so that brings me to the heart of today's vlog, the most recent discovery and the prospects of finding alien life on another planet. So what's happened? Well, a team of scientists has discovered signs of a gas in a planet called K2-18b, which on Earth, that gas is only produced by simple marine organisms. And according to Professor Niku Madhusudan of the Institute of Astronomy at Cambridge University, quote, "This is basically as big as it gets in terms of fundamental questions, and we may be on the verge of answering that question." So he goes on, "The amount we estimate of this gas in the atmosphere is thousands of times higher than what we have here on Earth. So, if the association with life is real, then this planet will be teeming with life. And if we confirm that there's life on K2-18b, it should be basically confirmed that life is very common throughout the galaxy." He goes on finally, "This is a very important moment in science, but also very important to us as a species. If there's one example, and the universe being infinitely large, then there's a chance for life on many more planets." End quote. Okay? So the conventional wisdom estimates, by the way, that there are some 100 billion planets or stars in our galaxy. Okay? Many of these are filled or should have different types of planets on them, many of which would be the gas giants like Jupiter and Saturn in our solar system. Others then are too hot or too cold to support liquid water, which is thought to be essential for life. But many are expected to be in what the astronomers refer to as the Goldilocks zone, where the distance is just right to support life, not too hot, not too cold, and all the other elements should align properly under these ideal conditions. And so again, this Goldilocks zone, if we can discover planets that meet these various criteria, then these are the specific areas where we should be looking. And as these exoplanets have been discovered, the scientists have begun to develop instruments to analyze different aspects of the planets, and most importantly, their chemical compositions, and specifically with respect to their atmospheres. So that's what's been happening. So the idea was then to capture a tiny amount of starlight glancing through the atmosphere and study them for chemical fingerprints, molecules, and those specifically which on Earth can only be produced by living organisms, the so-called biosignatures. So that's what they're looking for, and that's what they think they've discovered. And again, thankfully, in recent years, we've developed the kinds of instruments that allow us to look for these biochemical signatures. NASA's James Webb Space Telescope, or the JWST, which detected the gas on this specific planet, is the most powerful current space telescope ever built. And so its launch then in 2021 generated tremendous excitement that the search for life was now at last within humanity's grasp. Now, in the case of K2-18b, it's 2.5 times the size of Earth, and it's about 700 trillion miles, or about 124 light years away. The distance, of course, far beyond anything we could even imagine traveling with our current technology and understanding of physics. So the Cambridge group found that the atmosphere seems to contain this crucial chemical signature of at least one of two molecules that are associated with life here on Earth, dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. And so again, on Earth, these gases are produced only by marine phytoplankton and bacteria. So, but just as with anything, the JWST has its limits. It can't detect faraway planets that are as small as ours, specifically, or as close to their parent stars because of the glare. So NASA is planning the Habitable Worlds Observatory, HWO, scheduled for launch in the 2030s, which will be able to spot and sample the atmosphere of planets similar to our own. So again, look for that in the next decade. Also coming later this decade is the European Southern Observatory, or ESO. It's specifically the Extremely Large Telescope. I love that name, the ELT, which will be on the ground, but then looking up through the crystal clear skies of the Chilean desert. Again, scientists then hope to generate enough data within a couple of years to demonstrate categorically that K218b has some kind of life rooted in, again, certain biological signatures. Yet, even if that does happen, it's still not definitive proof, right? Instead, that means what we'll have to do is investigate further whether or not these biosignatures could be produced by non-living means. And if not, well, that would be confirmatory evidence. According to Professor Catherine Hymans of Edinburgh University, quote, with more time on telescopes, astronomers will get a clearer vision of the chemical compositions of these atmospheres. You won't know that it's definitively life, but I think the more data that's built up, and that if you see this in multiple different systems, not just one particular planet, this would give us more confidence, end quote. So a more definitive discovery then would be, of course, to discover life in our own solar system, ideally, using robotic spacecraft containing portable laboratories. Any off-world bug then could be brought back, could be analyzed, providing prima facie evidence to at least significantly limit any scientific research or pushback that might ensue. So you'd want to be able to at least provide some kind of evidence to continue to generate this kind of, this interest and this, the logic and the justification to continue our investments accordingly. And so the scientific case then for the possibility of life or past life in our own solar system has definitely increased in recent years following the data sent back by various spacecraft. So several missions to search for signs of life are on the way. It's an exciting time to be alive if you're into this sort of thing, or if you're an astrobiological physicist. The European Space Agency's ExoMars rover, planned for launch in 2028, will drill far below the surface of Mars in order to search for signs of past and possibly present life forms. So that's something to look forward to in the not too distant future. Given the extreme conditions of life on Mars, however, the discovery of a fossilized past life is probably the more likely outcome. If there was life, then it's deceased, shall we say. It's extinct. But it may have come in some other form at some earlier time in Mars's history. We don't know definitively yet. And then you have China's Tianwen-3 mission, also planned to be launched in 2028, which will be designed to collect samples and bring them back to Earth by 2031. And so NASA and ESA each have spacecraft on their ways to the icy moons of Jupiter to see if there might be water there and possibly even vast oceans under their icy surfaces. So again, we just don't know. Three things, though, are required in our view in terms of the production of life, the emergence of life: a heat source, liquid water, and organic or carbon-based chemicals. And so if we have those three ingredients, then the chances that life is able to form rises dramatically. So that's what we're looking for. Even so, we still have to be cautious. If simple life forms are found to exist elsewhere, then there's no guarantee, though, that more complex forms have necessarily evolved. We just don't know. Again, the next step is equally crucial and huge, going from simple life to complex life. And how that happens, or under what conditions precisely, again, we're just fascinated to know or to find out if it's possible. Again, we only have detailed and yet quite imperfect knowledge of our own Earth and life's evolution, to say nothing of what might have evolved in other places, in other parts of the universe. It's an extraordinary undertaking, no matter how you slice it. And so I've often thought it'd be great if other intelligent life from other worlds would just simply make it easy on us and contact us, because we're such, babies in a galactic and universal sense. Yes, we have intelligent life, although some might question that, but our ability to travel beyond our solar system is currently impossible. I mean, at least in our human physical form. And our technologies and our current knowledge of physics and astronomy and so forth are still quite limited in terms of these types of questions that we're posing. Again, I don't think they're impossible to answer. It's just that we're a long ways from providing the definitive answers that we might seek. But we're making progress, and that's what's fascinating. So again, if some other intelligent life is out there, please just contact us directly, okay? Don't be all secretive and just talk to certain governments or what have you, right? But that would be really cool, right? If they could communicate with us in some type of language or some means through which we could understand the common person, as it were, if they could reach us and had all of the necessary advanced technologies and knowledge, etc., really, they'd be like a god to us, right? And who wouldn't want to meet God directly? Anyway, until that happens, or at least for now, may you and yours continue to create peace in your lives, nurture love in your hearts, and dole out hugs in abundance, but especially to any extraterrestrials you might encounter along the way. Strike up a conversation. Say something like, "Care for some intelligent conversation?" Good luck. We'll see you soon.